Let's talk about the words risk and risk premium. So risk is generally measured as a deviation from expectation, like the standard deviation. Given that I have some expectation, how likely am I to be very close to this? How likely am I to be very far from this? And we'll talk about this in a fair amount of detail this semester. We can look at the total deviation. We can look at deviation caused by specific factors. Factors might include market cyclicality, or the size of the stock, or the relative value of the stock, or momentum, or operating profit, or how the company is investing, or other commodities. All these considered commodity risk. These are all factors. Just as a quick aside, cyclicality versus seasonality, just to make sure we understand the difference between these terms. Seasonality means selling more at Christmas and less in the summer, and cyclicality means selling more when the economy is doing better and selling less when the economy is doing worse. And the standard way we measure cyclicality is the CAPM beta, and I promise we'll spend a fair amount of time on this as well. Okay, so what about deviation from expectation? Should we only look at one side, or should we look at both sides? So should missing the expectation on the upside, which is good, count the same as missing the expectation on the downside? For the most part, we're going to look at two-sided, not one-sided, but we'll spend a second talking about some one-sided stuff. Okay, the argument, by the way, for looking at one-sided, I think, is fairly obvious that if I do significantly better than expected, that shouldn't be risk, because risk is bad, although you can define risk as any sort of deviation. The argument for using two-sided is that there isn't a lot of evidence that you can design an investment or some other, in many, many situations, such that you're only going to miss on one side and not the other. If you're going to miss, you're going to miss. Anyway, that's the argument. And we'll talk about something called the Sortino ratio very briefly, which is a single-sided measure as opposed to a two-sided measure. Okay, so that's risk. Risk premium is return relative to a risk-free investment. And so it's a little confusing because it has the word risk in it, but it's really a return measure. And it's measuring how much I expect to earn, or how much I have realized, relative to what I could have earned without incurring any risk. And so even though the word risk premium the term risk premium has the word risk in it, it's really a return measure, not a risk measure. It tells me how much extra I earned from having incurred risk. And the risk-free rate can be the T-bill rate, or maybe a money market rate, or something else, and we'll be fairly clear as to what this is. Okay, so when we combine these two, when we combine the risk premium and the risk in a ratio, we get the Sharpe ratio. And the Sharpe ratio is the risk premium relative to risk. And some people consider it a reward to risk ratio. How much did I earn relative to how much risk I incurred? It's really a risk premium to risk ratio. So, big question about this, and this is what we'll talk about very, very quickly, is does the Sharpe ratio correctly measure risk? Well, it depends, and this is an important point, because the risk measure for the Sharpe ratio is just the standard deviation. If I have returns that are normally distributed, then I can fully describe all the risk associated with this distribution, this investment, with a single parameter, standard deviation. If it's not normal, then maybe the Sharpe ratio is not correct. And let's look at a couple of quick examples in which using the Sharpe ratio might not really be a good measure of reward to risk or risk premium to risk, because the denominator isn't accurately describing risk. So the first example is writing insurance, and I'm going to insure a single car. And I'm going to insure just one car. I'm going to insure your car, and I'm going to put up $40,000 as capital, and I'm going to collect $4,000 a year in premium. And either there's no event or there is an event. We're just going to make it nice and simple. Either you wreck your car and I give you the 40 grand, or you don't wreck your car and I keep the 4 grand. And let's assume that there is if there is no event, I earn 10%. And if there is an event, I earn 100%. And so if there are no events ever, every year I collect $4 on this $40,000 and I make 10%. And I never have any deviation from that, because in every single year I'm collecting the same return. And so my expected return is 10%, and my historic average return is 10%, and there are no deviations from this, and so I have a zero standard deviation. And so I have an infinite Sharpe ratio, because the risk relative to the reward relative to the risk is 10% divided by 0, and I get 100%. And so I have a really, really, really good Sharpe ratio. Obviously, this is an extreme example, but here's another one that we could do. I'm going to put together a fund, I'm going to collect some investor money, and I'm going to use it as margin to write out of the money call options. Meaning that if a stock is $100, I'm going to write $110 calls. And I'm going to write 3-month $110 calls. I'm going to do this 4 times a year. And as long as the stock price doesn't increase by more than 10% in any quarter, I get to pocket the premium. So I'm going to earn somewhere between 5 and 10% on the money collected in every year. And as long as I don't have any bad events, I make money with very, very, very little deviation. And we're going to see that, in fact, this isn't really a normally distributed outcome because most of the time I'm going to make very little, but there could be some very low probability event in which I lose everything. And therefore, if I compute the risk to reward ratio, the reward to risk ratio using, well, the standard deviation, as long as I don't have any bad events, I make a lot of money with very low risk. The Sharpe ratio is not a good measure. And let's just draw what the distribution might look like for these. So let's graph a histogram of outcomes, a essentially distribution of outcomes for these 2 examples. And remember, the 2 examples are writing insurance on a single car or writing deep out of the money call options. And so I will just draw a line here, and here I have 0%, and here I have, say, 10%, and way out here I have minus 100%. And in any year in which nothing bad happens, I make somewhere around 10%. And so I will draw a histogram of all of these returns. And absent any bad outcomes, I'm going to have returns that all equal or very close to 10%. So I'm going to have an expected return of 10% minus some risk-free rate. So that's going to give me my risk premium, which is the numerator. But my denominator, absent any bad events, is going to effectively be 0. Now, because I just haven't incurred any bad events. Now, I could say, well, I have my 1 bad year, and now I have lost 100%, so here's one outcome down here at negative 100. But I can still see that even with a single poor event, if I look at the data, I can see that this really is not normally distributed. And if I were to write a model that says that, well, the expected return minus some risk-free divided by some risk measure, this being my Sharpe ratio, I'm not going to accurately measure the risk because this is obviously not normally distributed. And so the point is that the Sharpe ratio, which measures reward or expected reward, and that's an F for risk-free, relative to risk, doesn't really hold if the risk is not normally distributed. And we can think of many examples in which this is true. Other ratios we'll talk about the Treynor ratio, which is going to be the risk premium, which is, we're going to return measure relative to the risk-free rate, divided not by total risk, but by CAPM beta. And we'll talk a lot about the difference between total risk measured by standard deviation and market risk measured by CAPM beta. And then we'll also look at the Sortino ratio, which is going to be not necessarily the risk premium, it's going to be the risk minus some target or minimum acceptable return, often the risk-free, but the denominator is the big difference. Instead of having the standard deviation, we'll have a semi-deviation, which is just sort of half of the standard deviation of just the downside. And so this measure, the Sortino ratio, the risk measure, only gets larger if you miss on the downside. It doesn't get larger if you miss on the upside. And we'll do this as a separate exercise.